Good afternoon, everybody. Thank you very much for coming back from lunch. It was quite hard, I know, from my own experience. It was enjoyable to meet colleagues and catch up in real life, and I appreciate you making the effort to come back and listen to our next panel. As I promised in the previous session, we are transferring, segueing beautifully into the next session, which is not surprising given the quality of the organisation that we're working with here. We're going to be talking about safe and secure waterborne transport, and I think that picked up on quite a lot of the issues that were raised in the digital piece before lunch. So I'm going to hand straight over, because I will be strict with time, to Lanfranco Benedetti, who is Maritime Safety Unit at DG Move, and he's going to talk to us for a short while to introduce this topic. So thank you. Lanfranco.
Thank you. Okay. And good afternoon to all. I am Lanfranco Benedetti from the Maritime Safety Unit in DG Move. Now, before going into the matter at hand, here just 1 minute to explain what a Maritime Safety Unit does, actually. There are several thousand pages of legislations, directives, regulations, guidelines of mandatory character or voluntary character that are under the purview of the unit and of the Waterborne Directorate at large. This ranges basically on all areas of shipping, from port state control to training of seafarers, port reception facilities, flag state engagement, roles and rules for recognized organization, passenger ship safety, marine equipment, and so on. And every day, as we speak, these thousands of pages of legislation and rules are implemented across the 27 member states. And our role is to keep this correctly implemented in a uniform way, updated and maintained over the years. And it becomes immediately evident why the R&D activities are so relevant for our work, because gives us the hints and the direction of where we should go for the next years with our rules and regulations. Now, safety is for sure not the most glamorous subject, especially after having heard about autonomy, about zero emission, and fight against greenhouse gases. However, it's something we can't do without. An accident on a highly automated ship or on an ammonia vessel would set us back a decade if we do not implement this correctly and safely. So the challenges that we have ahead under the angle of safety, we heard throughout the morning, and I'm not going to repeat them. Maybe only one little additional element on the preparedness of the maritime workforce at large, because this is something that is for sure must be in the focus, especially in the light of the changing that are happening technology-wise. So keeping this up to the job, it is certainly one of the challenges that we have before us. Now, going a step deeper in why we are here and we should be here, I would like to say that the importance for us of your work, it comes before and after you do this work. Before, because we learn from your previous results to see what are the gaps and to understand what are the challenges ahead of us. And immediately after, when you have completed this work, to guarantee that the good results are uptaken into the regulatory framework, being this the International Maritime Organization, so at global level, or at European scale. And therefore, here it's a point that we have been repeating over and over, and on which there is a common and shared understanding in the Commission that despite these are research and development projects, and their focus is science, technologies, new technical solutions, for our regulator angle becomes important that we are provided, while you do these studies, with safety assessment, risk assessments that are prepared to be used in a regulatory framework. So our constant quest is to foresee in your projects this angle and a line for developing this type of work while you do these exercises. And this comes very nicely with the projects that are in this session today, because, for example, Flair or SafePass came exactly from this need back in 2016-17, after the IMO concluded the first or second review of certain safety requirements. The continuation of this work was taught through these research and development projects. And this, of course, applies now with the new priorities of the Commission, or if you want, a renewed priority of the Commission's greening and digitalization, also and more forcefully on these two domains. I think that I am more or less done up with my time. I would like only to point you to a recent report of the Maritime Safety Agency, the European Maritime Safety Agency, the EMSA, that is called MSAFE 2022, if I'm not mistaken, which is by the way open for comments and consultation online, but which contains, more importantly, a little bit the systematic analysis and review of the safety challenges that we have ahead of us. And thank you very much.
Thank you, Lanfranco. That's really helpful. So MSAFE 2022 online, we can have a look at that as we need to. So thank you for that presentation. That was very helpful. I'm going to move on now to talk a little bit more about the projects, and we've got the project offer from CINEA here. Anna Caramigo, I think I got it. Yes. Yeah, I didn't do too badly. So Anna is going to talk about some of the projects and that have been undertaken again through Horizon 2020 and come up with some conclusions, I believe.
Hello, good afternoon. My name is Anna Caramigo. I am project officer at CINEA, and my presentation will follow the presentation of my colleagues, which means that we will focus on three main points. We will discuss about the main challenges under Horizon 2020 program regarding safe and secure waterborne transport. the budget distribution of Water-Borne portfolio, and the key objectives of Horizon projects that fall under this category. As Magda said earlier, as Fotini said earlier, Waterborne transport needs to be, before all, safe. And it is safe, safer than ever before. However, safe operations of cargo vessels remain a challenge to be addressed, also in the light of the increasing use of northern sea routes. In addition, the significant and continuing growth in the size of cruise ships and the expansion of their operating areas to remote regions and particularly difficult environments has created a new and increasing risk. Strong regulations that are put in place and also technology innovation can ensure that such accidents are rare. Horizon program has focused on improving safety, including the human factors, and this focus continues in Horizon Europe. Moving forward, we will address the challenges that are addressed under Horizon 2020. So the calls ask the participants to radically redesign the evacuation systems for passenger ships, to greatly enhance the prevention and management of fires at sea without recourse to external intervention, to develop and demonstrate innovative solutions for ship design and waterborne operations in order to avoid and mitigate passenger risks and ensure high levels of safety, to improve the observation and predictions of oil spreading in the sea using novel online sensors on board vessels, fixed structures or gliders, to build the enabling knowledge, technologies, and operational procedures and test them in a real-world environment with the aim of guaranteeing safe and environmentally sound waterborne operations. Also, to improve transport safety through a more timely, focused, and integrated adoption of human factors in the design of vessels, and of course, minimize the human error. Finally, to develop solutions that address these risks and can be reflected within forthcoming revisions of relevant IMO rules. Safe and secure waterborne transport operations as projects represent 16% of the waterborne transport budgets, which means 9 projects with a total net EU contribution of 75 million and more than 200 beneficiaries that have participated in. You can see here the pie charts, as my fellow colleagues also showed. And since I wouldn't like to spoil the presentations of the coordinators that are coming up next, this slide shows the key objectives of the Horizon 2020 projects under this topic. For example, GRACE focuses on developing and comparing and evaluating the effectiveness and environmental effects of different oil response technologies in a cold climate. Below we have CINEA, which is a research project that develops an innovative and integrated risk-based approach to safe Arctic navigation, ship design and operation. Efficiency 2, which deals with the improvement of navigational safety and efficiency, showcasing solutions in 2 very different regions, in the Arctic and the Baltic. We have Palaemon, which proposes the development and evaluation of a sophisticated mass centralized evacuation system. And I think we had a question about evacuation. And they tried to build a radical rethinking of mass evacuation vessels combined with intelligent ecosystem through the access in real-time data. We also have Lashfire, which is a research project aiming to reduce the risk of fires on board RoRo ships. And of course, Safe Mode, which addresses the question of how to fully capture human elements and their interaction with other system elements to enhance safety in maritime and aviation. Their aim is to develop a novel human risk-informed design framework in order to identify, collect, and assess human factors data. You are very welcome to visit their websites and find out more in the project websites. And this concludes my presentation. Thank you very much.
You're all being very good. Thank you, Anna. That's excellent. So we're going to go now to look at the projects that have been co-financed through Horizon 2020, look at what we can learn from that previous work and apply it to the future as we go forward into Horizon Europe. So we're going to start with another difficult Greek name for me to pronounce, Apostolos di Papanakalou. Apostolos Papanikolaou. How did we do? Oh, not great.
Great. I think you made it by the first trial. Thanks to Anna.
Your presentation now.
Thank you. Can we have the first slide, please? I have the pleasure to present you the Flair Project. That is a project about maritime safety and specifically about the safety of passenger ships and passenger shipping. This is a domain of European shipbuilding industry and also shipping industry. And so far we have here a consortium of more than 20 partners where we can see that all major representatives of maritime safety in Europe are there. The big four Euro yard shipyards, shipping companies, classification societies, research institutes, software houses, and also knowledgeable academia. The project is coordinated by Balance, and we have also an international advisory board in which we have represented major European maritime administrations, including EMSA, the European Maritime Safety Agency, also the US Coast Guard from overseas. That is a very important partner, especially when we are discussing the results at IMO. The Association of Shipping Companies, passenger shipping companies like CLIA, cruise liners, and Interferry for the ferry operators. All these representatives help us to go the right way with the project. The next slide, please. Well, accidents of ships and with disastrous outcome have been known for centuries, and everybody knows the tragic loss of Titanic 110 years ago with 1,500 victims. However, we had exactly 10 years ago another disastrous accident, the Costa Concordia, that was a cruise ship carrying 4,500 passengers, fortunately with only 32 victims. It sank in front of the island Giglio of Italy. And before we had Express Amina in front of the Paros port, Greek island Paros, with 80 victims, and the Sea Diamond in front of Santorini Island, that you see in the picture to the right below. All these accidents showed the vulnerability of passenger ships against side and bottom grounding. Grounding is an accident type that has been not satisfactorily considered until now in present regulations, especially in the SOLAS framework. SOLAS is the international regulatory framework for safety of life at sea, in which long-breaking damages that they happen in grounding accidents, even the Titanic accident was a long-breaking damage, are not satisfactorily considered. We have investigated this particular accident together, of course, with other type of accidents like collision accidents, and have defined a harmonized framework how to approach this kind of accidents and so the consequences. We have to note that until now, collision accidents are the basic scenario for SOLAS that we satisfactorily address in present SOLAS regulations. However, as we have seen, grounding accidents become more and more important. And in fact, please, the next slide. We see from statistics that the frequency of flooding due to collision for cruise ships is only 20%, whereas the remaining 80% are due to grounding, bottom grounding or side grounding. With respect to the risk, that means in terms of the fatalities created, only 5% of them for cruise ships are due to collision, whereas the 95% are due to grounding events. Likewise in RoPax ships. Next slide, please. Here we see the pathway of developments of present regulations, the SOLAS regulation. It started actually in early 60s with SOLAS 60 with deterministic regulations. If we say deterministic, we mean semi-empirical approaches to the damage stability of ships. Later on in middle of 70s with SOLAS 74 and H2020, we have the introduction of a probabilistic approach to damage ship stability. That means a risk-based approach. That was applied at first only to cargo ships and optionally to passenger ships. We had then in between some very notable accidents, especially the Herald of Free Enterprise in '87 and the Estonia accident in 1994 with close to 900 victims in the middle of Europe, in the Baltic Sea. These were accidents in which the so-called water on deck problem on RoPax ships was an urgent thing to be considered and was later considered. However, as I said, the grounding accidents have been not satisfactorily considered even in the latest SOLAS 2020. In this pathway, we see also a series of EU-funded projects that supported international regulations. And we were happy, actually, the consortium that participates in Flair participated in all these developments across in the last 30 years. The next slide, please. So where we are now in SOLAS, we have a harmonized probabilistic approach. If I say probabilistic, that means a risk-based approach to cargo and passenger ships safety, even beyond flooding accidents. Additional, of course, we have higher requirements for passenger ships compared to cargo ships because of the risk of many people on board. On the other side, collision damage stability assessment is based on accident statistics of cargo ships, mainly of cargo ships. And this is due to the fact that the accidents with passenger ships are very few, thus we cannot draw out of them sufficient statistical data. The water on deck problem on RoPax ships is now considered in the rules. Bottom grounding is only considered via deterministic requirement for the double bottom height. That means a semi-empirical approach. And damage stability and evacuation studies are only linked in an indirect way, an empirical modeling, whereas it is very important to see how much time actually is remaining for properly evacuating a ship in order to do a risk assessment. Last but not least, the safety survivability of the ship after flooding is assessed by use of a required subdivision index, collision index, the R index. This is something that is based on an FSA, formal safety assessment, but is debatable whether we can keep this kind of index in the future. Next slide, please. Well, we are already beyond SOLAS with developments in research and also by the industry. The industry is nowadays using numerical flooding simulations that are state of the art. And in the Flair project, we have done numerical benchmark studies where international participants have been there and verified the results by model experiments. We have conducted evacuation simulation studies over many years, and the industry is using that. Design improvements by the industry are by simulation-based design, and this leads very often to contradictions to the simplified empirical approaches of present SOLAS. We have done intensive research in the last 30 years that deliver better insight into the flooding events and how to assess the risk of a ship sinking. And last but not least, the industry has also promoted voluntary measures to improve the navigation of ships and how to mitigate, in the case of accidents, the fatalities. Next slide, please. So this is the Flair project, the main objectives, work packages, and organization. In the heart of the project, we have the Flair framework and methodology that is practically a risk-based modeling of the flooding and its consequences. This could be eventually used by the industry, in this case, first by the shipyards, to create risk-based design demonstrators. And based on this outcome, we will go to IMO proposing a risk-based regulatory framework. Of course, this Flair framework is supported by the various work packages, namely delivering damage statistics, even simulation of damage extents by first principles. In this also in work package 3, crashworthiness comes into account and will be considered. Also, initial data are standardized and numerical simulation tools are also used as they were already developed and are now at the stage of benchmarking. And finally, also in work package 6, we have also variety of mitigation, risk mitigation measures, among them also evacuation simulations and other operational measures to reduce the consequences of the hazards. Next slide, please. Okay, here is the progress of this project through work package 5. You see here how this framework is working on the basis of input parameters that are delivered by a variety of work packages and former projects. We have the generation, probabilistic generation of the breach of the watertight integrity of the ship. Then we can conduct a static analysis, a simplified static analysis, or alternatively, a dynamic analysis of the flooding event by proper tools. Have also evacuation simulations, and finally, with this outcome, proceed with a risk assessment, ultimately to assess and calculate the potential loss of lives for the people on board. Next slide, please. What has been done and what we still need to be done now. We have applied the Flair framework to sample ships, but this needs to be applied also to a wider range of ships and designs. We need to make sure that the results are disseminated and made available to the international maritime community and regulators. This is, I think, a difficult task that will take some time because even knowledgeable authorities outside Europe will need some time to catch up with these developments. And without teaching this, it will be not possible this to be accepted at IMO. We need to perform formal safety assessment and to establish the required level of safety, ultimately not in terms of a subdivision index like we have until now, but in terms of a risk indicator like the potential loss of life of people on board. And this is actually an indicator also used by other industries in safety products. And last but not least, we need to find the connection to IMO. This, of course, through the European community. We have already done a Flair presentation at the European Union's Passenger Ship Safety Group last December, communicated our results and asked for support in promoting our results. Next slide, please. What Flair ultimately will deliver is more tangible results that can be used, harmonizing and standardizing the input parameters for risk assessment of passenger ship flooding, then have a suitable process to combine static and dynamic, that means first principle simulations in a framework, to have standards how to perform and approve numerical simulations and numerical simulation tools, a validation of risk control options for sample of ships, combining also flooding and evacuation simulations in order to see whether it is enough time for people to properly evacuate. And finally, the proof of concept needs to be confirmed by the end users, the shipyards, class societies, and operators. Next slide, please. The way ahead to IMO beyond today, you see that ultimately goes a decade in front of us. We know that this process is tedious. as others need also to catch up about the concepts developed in the Flair project. But our plan is systematically to submit papers through the European Union to IMO and discuss this so that maybe the next amendment of SOLAS, maybe SOLAS 2032, can be risk-based regulatory framework and based also on the outcome of the Flair project. The next slide, please. Okay, I come now to the last slide. We have a lot of dissemination activities. You can see these activities on the internet, a variety of webinars, monthly webinars. The second one was a few days ago, the next one on the 3rd of March. And we have also many presentations in international conferences, international fora, publications in peer-reviewed journals. We hope that in the next time, more people will be supporting this risk-based regulatory framework as we implement in the Flair project. Thank you very much.
Thank you, Apostolos. Thank you very much. Very interesting to see real live research pushing existing regulations. So we're going to move on now to talk about the safe evacuation of ships, and that's a presentation that's going to be given to us by Melinda Cuthie, who is the Director of Business at the Department RTD for Talos. So thank you very much, Melinda, my apologies.
Thank you very much. It's a pleasure for me to present the project to you today. If I can have the first slide, yes. So just clicking on the next slide, I will give you a snapshot of the Lincius to Market project. It had the title Innovative People Localization System for Safe Evacuation of Large Passenger Ships. And it was founded under Horizon 2020 with a duration of a little bit more than 3 years and the total budget of over 10 million. Actually, it was a continuation of an FP7 project called Lincius, where these innovative technologies were tested in a lab and in small scale. So just going to the next slide. I will just underline the need for such kind of projects, and I will repeat a lot of things that Mr. Papanikolaou just said. Actually, the need for this project came from real life because of some maritime disasters, as Mr. Papanikolaou mentioned before, in 2012, but also in 2014, the South Korean ferry or Norman Atlantic, the accidents that caused several lives lost. And some marine professionals approached us expressing the need for a system that can maximize the efficiency of safe rescue and at the same time minimize the loss of life, making passenger ships safer. So just if we go to the next slide, I will briefly present you the consortium. I think that one of the key success factors of this project was the consortium. We had a partner covering all the expertise that we needed in order to successfully implement the research project. So just if you can click on it, I will show you that we had the technology partners. Can you click on the next slide, please? The technology partners, you can see that we had from life-saving equipment, smart life jackets, the signal processing, all aspects of the technology was covered. With the next click, I will show you that we also had the marine professionals in the Maritime organization. They knew exactly what are the processes and procedures for safe evacuation, because the system had to meet those requirements and had to be adjusted to those system processes and procedures. We also had Lloyd's registers for the type approval part and played an important role in standardization. With the next click, I will show you the associations that participated in this project, the Spanish Maritime Sector Association, and also a Smart Fabric Association from Spain for the smart life jackets. The next category that I would like to show you is the cruise ship operators, Louis Cruises and Royal Caribbean cruise ships. It was very important because we needed the ships to demonstrate the technology. With the next click, the Joint Rescue Center that helped us for the search and rescue exercises to demonstrate the overboard system. And then just two more categories that I will show you. Next click, please. It was our company for the project management. And then the last but not least is the International Advisory Board, with very prestigious partners there as well, that helped us with their continuous advice to implement this project properly. So the next slide, I will show you the technologies that we developed. Actually, there were four categories. One big category of technology was the onboard localization of passengers and crew during emergency, tracking and counting people in emergency, wearable locator devices such as life jackets, smart life jackets and bracelets. And we had a hybrid wired and wireless localization system installed on ship. Also, we had another big category, passenger behavior and health monitoring. We had the life jackets and bracelets with embedded sensors that could send information, that can send information about the passenger movement, their temperature, dryness and wetness, and their health parameters. Another big category was the software part, the decision support system. We called it real-time disaster management, which could give status about monitoring of the disaster status, guide evacuation teams. It can predict the spreading of the disaster, and it was a disaster management and advanced disaster management based on the ship sensor information. And the fourth big category is the overboard localization. With the sensors embedded in the life jackets, it could enable the localization in extreme environmental conditions and also during the night, which is something very challenging for search and rescue teams. And we also had a UAV with radars mounted on it that could also send the information to the research and rescue team. So if we go to the next slide, I would like to show you the achievements that we had. The onboard system was demonstrated large scale in May 2018 on the Rhapsody of the Seas cruise ship. This is a cruise ship with almost 300 meters length, 12 decks, and the capacity for 2,500 passengers and 800 crew members. So here you can see real pictures from our large scale demonstration. Where we could count the people on board, we could localize them. You can see the screenshot from the decision support system where you could, the crew and the captain could see the different decks, the incidents, and also could localize people, both passengers and crew members real time. This is very important. In the next slide, I will show you the achievements regarding the overboard system. So here, this took place also in May 2018 during a multinational exercise where we have released the life jackets in the sea. You can see the UAV that could be launched from the ship and also a handheld device that could localize the life jackets. So both the UAV and the handheld device localize the life jackets and send real-time information to the coordination center where you can see the search and rescue team having all the information in the monitors in front of them, and they could take the best possible decision based on the information that was sent to them from these sensors, and just a picture of the UAV that could land after the operation with a parachute. So if you go to the next slide, I would like to show that another achievement was on the field of the standardization activities where Lloyd's Register took an important role. We have submitted an ISO standard under ships and marine technology, life-saving appliances and arrangements for localization systems for the safe evacuation of persons from ships and offshore structures. And actually this standard provides specific performance and test requirements for people localization devices in order to assist stakeholders when developing such systems for evacuation. So my last slide is about the exploitation of the research results. If we can go to the next slide. Yes, thank you. So we had in the consortium Autronica, which is already a major supplier of cruise ships, and it's a well-known and well-trusted name in the cruise ship operator. So we based our exploitation strategy on Autronica. We had all the necessary agreements in place during the duration of the project. We had a joint ownership agreement and an exploitation agreement in place. And actually there was a huge interest from several cruise ship operators. The problem is the pandemic that came just right after the end of the project that severely affected the tourism sector and the cruise ship sector. So basically in 2020, the cruise ship tourism was stopped and prohibited. And even now that it started again operating in 2021, it is at very low levels compared to 2019. So I believe that the exploitation of results will continue as soon as the cruise ship sector recovers from the pandemic. Let's hope very soon. So with the next slide, I will just thank you for your attention. And I will be here for any questions later on in the Q&A section. Thank you very much.
Thank you, Melinda. Great presentation, thank you. So the last presentation we're going to hear today is from SafePass, and that's going to be given to us today by Lazaros Karagianidis. That wasn't too bad, I hope. So, Lazarus, how are you? Good afternoon. Thank you for joining us.
I'm fine.
Would you like to talk to us about personalised evacuation?
Exactly. So if we could start the presentation. Thank you. I think we can skip the outline. First of all, let me thank you for inviting us in this interesting workshop and give us the opportunity to present SafePass and its current achievements so far. So SafePass is a Horizon 2020 project. It is a research and innovation action, and it is a 36-month project that started in September 2019. And we have 15 partners from 8 different EU countries, as you can see here on the map, where National Technical University of Athens is the coordinator, and I'm representing here the coordination team of NTUA. Next slide, please. If we have a look at the SafePass consortium as a whole, we can see that we have a quite diverse range of partners. 3 academic institutions, NTUA, Strathclyde University, and Trinity College of Dublin. Then we have 2 classification societies, DNV and RENA, 5 innovative SMEs and industrial partners that develop several solutions and technologies such as Exus, Telesto, Crowd Dynamics, CS Group, and Cibility. Of course, 1 shipyard, which is Chantier de l'Atlantique, as well as 2 LSA manufacturers, Viking and Servitec, and of course 1 cruise line operator, which is the Royal Caribbean Group, that is also providing us their cruise ship for the pilot demonstration. Next slide, please. So let's have a look what is SafePass about. Our main aim in SafePass is to actually redefine the evacuation process, the evacuation systems and equipment for large passenger ships in all environments, hazards and weather conditions. And our main target is here to significantly reduce the total time required for ship evacuation, while improving the safety both for passengers and crew. So we could say that our main vision here is to make ship evacuation and abandonment of large passenger ships safer, faster, and smarter. Next slide, please. Now, the SafePass main outcomes could be tailored into, let's say, 4 main pillars. The first pillar is the technological part. We are developing and designing and developing mainly location-based supportive technologies for both passengers and crew, as well as training applications. The second technological, let's say, leg is the software and the situational awareness component. Here we're talking about a common operational picture and the crowd simulator that can provide enhanced situational awareness as well as early warnings and evacuation management. The second very important outcome of SafePass is the design and the development of novel life-saving appliances, lifeboats, as well as personal survival equipment, as well as novel entrance passages and architectural structures. And the third pillar is the risk modeling tool that we're developing that is for flooding and for fire scenarios, and also calculates and provides risk mitigation and control options. While the fourth pillar is our intention to provide submissions of future recommendations to the IMO. And we are following here an evidence-based assessment and socio-technical analysis, and be compliant also with ethics and GDPR, of course. And this is done through several workshops and interviews with crew members, with safety experts, with the executive advisory board and passengers as well. Next slide, please. Now, if we have a look at the smart technologies that we referred in the beginning, here we are mainly developing 4 types of different technologies. First is the smart life jacket that provides indoor localization technology, as well as haptic and audio navigation to the passengers in need. These are all technologies meant for supporting the existing systems, not to replacing them. A smart wristband that is meant to be used for passenger association, as well as for measuring the physiological sensing of the persons in an evacuation scenario. Then we have 2 types of augmented reality application that we are designing and developing for crew and passengers. The one set of, let's say, training application is based on augmented reality glasses for training crew members and maintenance staff on LSA operation, while the other is on a mobile phone for, again, for passenger support in case of an emergency. And we have also a development of a passenger mobile app that uses evacuation information, safety information, and also employs its own indoor localization system. Next slide, please. Here we can see some of our prototypes. So the common operational picture enables the interactive 2D and 3D maps and visualizes several alerts as well as the evacuation routes, and we can actually in real time track the situation, as well as integrate with existing safety management system on board, while the crowd simulator forecasts the crowd movement during an evacuation and calculates a dynamic near real-time evacuation route. And we can see also the holographic common operational picture that is an augmented reality version of this tool. And next slide, please. Now, if we have a look at the other types of prototypes, this is just a summary. Here we can see the smart life jacket with all the electronics and the devices that we are developing. The passenger mobile app that shows, for example, where exactly the passenger is located in case of an emergency. He knows, or he or she knows which route to actually, or which way to go to the nearest muster station or the safe exit. The dynamic exit signs, which are digital signs that can be manipulated by the operator in case there is a blocked route and needs to be a route needs to be rearranged. The augmented reality training application that provides the 3D model of a lifeboat and several training scenarios where the crew or the maintenance staff can actually interact with the 3D model and go through the different test scenarios and training scenarios. While the smart life jacket here, you can see 2 types of prototypes. The first, which was quite bulky, while the second employs sensor systems, as well as embedded artificial intelligence algorithms. Next slide, please. Now, with regards to the next slide, with regards to the novel life-saving appliances, the lifeboats and the mass evacuation systems, here we are designing two types of LSAs. The hard-shell LSA, which is designed to provide access to the LSA on several decks, as well as and deploys a launching mechanism using the free-fall launch method, while the soft-shell LSA is designed to provide flexible location for evacuation, to accommodate all persons on board, and to reduce as much as possible the crew actions. While the entrance arrangements, the passages, and the architectural structures are mainly meant in order to make the abandonment process more efficient, to accommodate the different motions they experience in heavy sea states, for example, and to improve in general, or to reduce the abandonment time. Next slide, please. Here we can see some screenshots from the first towing tank tests, where we have actually tested our models. So the soft and the hard shell model, where we've gone through several test scenarios for different sea and twin states. And we've analyzed the behavior, let's say, of those models with regards to their behavior, let's say, the optimum launching and navigation scenarios and so on. And in April, we will have the second round of towing tank tests. Next slide, please. And finally, our risk modeling tool. This is based on a high-level event sequence considering influencing factors in case of flooding and fire. The RMT can assess the evacuation and abandonment risk dynamically based on real-time data related to the passenger distribution, the route, the LSA availability, and so on. And by the quantification of risk to people, the evacuation and abandonment process, the risk model provides the basis for the identification of main risk contributing factors and the evaluation of risk control options. And here you can see a screenshot of our dashboard. Next slide, please. Now, going to the almost final slide about the exploitation potential and the challenges. We've already identified with our partners the potential commercialization of several systems or products of SafePass. Of course, here we are targeting mainly the ICT, the software industry, and the cruise line industry. And with respect to the LSAs and the lifeboats, of course, the LSA and the personal survival manufacturer industry and yards. And as a research project, of course, we are also targeting academic and research exploitation. With regards to the current drivers and barriers that we have identified so far, of course, the higher TRL technologies like the common operational picture is much more mature, let's say, for being commercialized than the lower TRL. On the other hand, the IMO regulations are both driver and barriers for several technologies. For example, for the LSA manufacturing process here, we are following the alternative design and arrangements by IMO. Of course, the risk control options, the societal impact assessment, and the demonstration campaigns and the demonstration pilots that we're going to have this month will also be a main driver in order to further exploit our results. And of course, our participation also in the passenger ship safety expert subgroup. And here I would like to thank DG Move and EMSA for their support, also towards our IMO submissions that we are planning to have within the next months. Next slide, please. And I think this is the last slide from my side. So please check our website and our social media. You will find a lot of information there. And thank you for your attention. I think the next slide is just the closing slide from CINEA. And once again, thank you, CINEA, for inviting us.
Lazaro, Thank you so much. That was really, really interesting. And I think it was such a good link between the last morning session and this one to start looking at how digital systems and solutions, AR and so on, can be used to help safety, to support safety as well as design and decarbonisation. So we have some questions. There's a couple that have come in online, and I think there are some in the audience as well. Let's take the live questions first, if we may. Would you like to go, sir?
Yes, please. My name is Jesus Carballosa. I come from CINEA in Barcelona, and I was all seafarer, okay? And I see in the presentations very high level of technology, very interesting and promising, covering the problems we have on the shipping now from the human factor. Some of the speakers were mentioning the skills, and Lanfranco was centering the subject on the importance of this. If you look now to the curricula of the nautical faculties or nautical schools, there is a very big gap between the technologies and the studies. And this is very risky because the gap is increasing, and then with the technology, you will not support safety, you will increase the risk because you have to domain the technology to be sure about what you are using. And saying that, I suggest that the urgent need of revision of the curricula at the European level to create a standard, because even today, there are different levels of training, and we have to unify this for finally one time, okay? Standards for education and training. Second, different aspect. On ships, we have humans still, because the unmanned ships that will take time to come, okay? And I didn't see yet to take into account the working and living conditions seriously, okay? And that we are humans on board, and if we don't want to finish like the truck drivers, that European level we don't find truck drivers nowhere, we will not find people at sea, because from the human point of view, we don't provide the needs the human have: communication, information, training, I don't know, some physical aspects. And this is very important, that we will finally, I don't know, it will be possible to start to work seriously with this. And the ship designers, they took care of the ergonomy of the bridge, but only of the bridge. And the rest of the crew where they are living, they don't care. They put a sleeping room, tarara, tarara, but not thinking about the ergonomy and the needs. Okay, thank you very much.
Two questions there. Thank you very much. They're both very, very important. Let's start with the first one. I don't know any comments about the gap between the curriculum and the skills the developments that we're talking about here. And if I understood you correctly, sir, that we're looking at creating in Europe a standardized curriculum so that we can bring seafarers up to the level of the technology developments that we're promoting. Has anybody got any points? Yeah, thank you.
There is an initiative, and I think it's from DG Employment, where you have a project for 4 years called SkillSea, and there exactly the education and training institutes are doing what you ask for, because I think we have the IMO, we have the STCW, but that still doesn't take care of a unified level in Europe when it comes to education and training. So the social partners, together with the education and training institutes in Europe, are exactly working on what you say, which does not, but in addition, in all of these projects, we also can identify, and that's what we also said this morning, what will be the effect or what has to be taken into account in the curricula. Because
What the problem is with the STCW, and that we know both, I think, is before it is updated, the technology is already out of date. So that is where a bit the issue is. But there is currently being done a lot of work, both curricula in terms of skills and knowledge, but certainly also in terms of competences, and how are you able to transfer these competences, because not all the schools have the practical training tools in place as well. So there is a lot of work being done in that respect, and we constantly have to have a look at it, because it may, otherwise the implementation of technologies will not succeed.
Brilliant, thank you. Anybody else have a comment they'd like to make? So I'm going to go on to the next question. I think it's important. Well, I know it's important. Ships are crewed by human beings, and they have to have adequate, good working and living conditions whilst they're on board and at sea. And I think it's never been more highlighted than it has been over the last couple of years in the pandemic, when we saw the plight of seafarers being brought to public attention, but very, very little action was taken about it. So I think it's an important point. I don't know whether it fits into any of the categories that we've been talking about today, but I do think it's worth bearing it in mind, and just I want to see if anybody has any views at this point about how we can improve those conditions as we go forward with the technology for the future. Is this another question, or is that a response to that?
Έπαφος Advisors. It will not, never, it can't be a ship or whatever without human participation. But on the nowadays we have to research and implement with the digital area, which is unknown to us, to see the reactions, to see whatever happens. But there will not be any kind of crew in the future without a team of people in the central computer of the ship, organizing and inspecting the artificial intelligence. But right now we are focused on the digital world. The already safety and the regulatory form of the nowadays ships are very good, at least at our Western world. Now, there is a question, of course. Before putting the question, I would like to thank the Linkeus to market, which is an ancient Greek. Linkeus, it was an animal and a man who was seeing very well. And the Talos, which was a robot in ancient Minoan times. I'm speaking for the Greek names. And the autonomy and the automated instructions, they are all Greek to you, and to me also. So the question is, as I'm participating also a lot of times in the SWIM project of the Eurocontrol, which is the air flights, and over there we have the ATM. We have the ATM platform, which is the aerial transfer management. We don't have. I didn't see in your presentations to such a huge project you are presenting to the European public something analogous, something like a sea traffic management. Already on the Marine Copernicus, we have through the satellite system some private platforms, but they are not in this level of your research, which is a very good one. But how we can make the research when we don't have the 100,000 ships, how they are circulating. And this also is nearby to the control and to the safety rules of the whole thing. So do you think, do we have, or have we should create something like this, like a platform which manages in the airport, in the air flights, we have 20 to 30,000 air flights in Europe every day.
Yeah. So the question you're asking is whether we have a similar approach to the maritime sector as a sort of air traffic control system.
Yes, we do.
Yeah.
Actually, there is already hard legislation on that. It's called the European Maritime Single Window, which, by the way, is not coming now because there has been already passed in the years the implementation of the national single windows, and now work is in progress to provide for the European coordination of this technically, with hardware and software that will be deployed as we speak, I would say, because colleagues are working on that and are only a few months away for the first implementation for the European coordination. At the same time, the vessel traffic monitoring system is in function since many years. EMSA is receiving 15 million AS points per day. So these things are already there. Of course, improvements driven by technology such as artificial intelligence methodologies can always be implemented, and we are also experimenting already this type of solutions. This to say that even when this thing will be fully deployed, the work will have to continue to keep pace with the technology development that will be certainly with us for the next few years.
Excellent. And I think that maps quite nicely into a question that we've had online, which talks about the, earlier in the event, we have been talking about, earlier today, we've been talking about projects in the Innovation Fund and so on that are likely to reach TRL 9, and looking at market rollout solutions for various green projects. And the question is, what similar programs are there now for safety-oriented projects? Do we have any other projects being lined up?
Well, I would say all of them. Because, as we said many times during the day, without this safety element, we go nowhere. And when there is a project aiming at deploying an ammonia engine on a ship, I would say that safety is very much at the core of it. And here is when really the greening and environmental element can't go ahead without being properly looked at under the safety angle as well. So the answer is really all of them.
Yes, also something to complement. Since safety now has taken another aspect, for example, the infection, Horizon 2020, Horizon Europe now, the new call, has also included this kind of aspect of how to control infection in large cruise ships, which is another aspect of what we are talking about safety now. For example, it's not only the flood, the fire, an accident, and also it is the infection, and this has been taken into account in this Horizon Europe call.
Peter, have you got intervention from the floor?
Yeah, it's Peter Crawley here again from DG RTD, but also to point out that CINEA are currently evaluating a topic which is addressing fire on large container ships and addressing avoiding navigational accidents, including using smart technology. And, you know, going forward, there are issues like the resilience and safety of digital and connected systems. So, you know, this is something that continues to be addressed, and it's also embedded in other topics which, for example, are addressing the deployment of fuels and the safety issues related to those.
Thank you, Peter. I think just from my own experience of leading an innovation project, it is impossible to move without addressing the safety issues, and that's exactly as it should be. So I think that's a really important. Have we got any more questions from online questions, anybody? No? Yes, they did promise me two, but I've only got one here. Anybody else got any questions? Ah, thank you. It's here, as if by magic. Okay.
This is for me, I guess.
Yes.
It is known that the lion's share of the Horizon Europe Waterborne Transport funding will go to zero-emission projects due to the Green Deal targets. However, do you have an indicative figure for the waterborne safety-related funding that will be allocated during this MFF, which means the New Horizon Europe. As an indicative budget, we don't have an actual number, no. Yes, Peter?
No, we don't have an indicative figure for the safety area, but for the zero emission activities, there is a budget for the partnership, for the zero emission waterborne transport partnership through Horizon Europe, and that's 530 million from the EU, leveraged, as Jaap was explaining, 6 times by additional commitments from the industry side.
Lovely. Thank you very much. Any other questions from anybody? So, looks like not. Jaap, do you want to just move straight on into the next part? Is Jane here? I thought that might be you. So this is the head of unit for low emission future industries, Jane Amela. And you're going to speak to us on behalf of DG RTD. Thank you, Jane. Thank you, Anna.
Thank you.
Sorry, I rather went ahead of the
Is it okay,
schedule.
the micro, or should I do something? Is it here? Here. I managed, I think. Thank you. Okay. So, yeah, I think I'm the only one in the room this afternoon, so I will start the concluding part of today. I could not attend in the morning, but I followed online, and I think it's quite a good conference. I think it's very important, I think, to present the project we are doing, because it's important to learn, to use this, to communicate on this, and to build up on this project for future projects, so to develop European leadership in innovative and green transport solution, but also as a feedback to our policy. I think it's very important for us to know exactly what is the science-based, to decide and develop our policies. Today we were looking at the 3 main aspects of our research and innovation action from the EU on waterborne. So it's of course, the main aspect today is the transformation towards zero-emission waterborne transport. Then, of course, we want to, in doing this, to stay competitive, connected, and automated in this sector. And I insist on the competitive because I will come back to it later. But I think for me, it's very important that that we develop these technologies and also create a market for it, that they are used in the market, because otherwise it's a little bit useless. And the third part is what we just had before, is a safe and secure waterborne transport. So I think, we have big challenge ahead of us. Of course, it's a very big challenge to have this industry and the EU economy as a while climate neutral by 2050. And our main instruments is, of course, the overarching is the European Green Deal, but we also have the smart and sustainable mobility strategy. So I think that's for us the basis. And as I said, we want to develop solutions taken up by the market. So we need also to look at the policy level, that we create markets for this business case, and not only at EU, but also international level, which is another big challenge. But I think we should keep this in mind. And if you look at our action, I mean, it was mentioned this morning by Gabrielle Mialok from CINEA, that in Horizon 2020, 25% of the budget for waterborne was dedicated to greening of the shipping sector. And today in Horizon Europe, we have about 75%. So I think, it just reflects our policy and our priorities at EU level. Well, the idea is really also to continue our efforts, so investing more money with this objective, of greening the sector, and also to, as I was mentioning, not only to have a theoretical solution, but also to deploy them, so to go to higher TRL, to projects with higher TRLs, and that's the goal. Also, I think what's very important is just to build up on what we have already done in Horizon 2020. It's very important, for instance, for something like batteries, which is also very important for the sectors, wind assistance technology, and also very important parts where I think we still have a lot of work to do is sustainable and climate neutral alternative fuels, because this is also something which is, of course, very important for this sector. And as I mentioned, we have to build up on what has already done in the past, but we also need to collaborate and to coordinate more intensively with other partnerships, other instruments, other projects at EU level, but also member states, regional level. So I think here what's very important is to look, for instance, well, we work, of course, at the Commission. We coordinate among our instruments, and you saw in the morning Dirk Beckers and Damien Meadows, so we also talked about other very important instruments for the sector, like CEF, like the Innovation Fund, and we are in constant contact with all these people from MOVE, from Klima, to just make sure we work in a coordinated manner. So I think it's very important. We also have, of course, we want to increase synergies and coordination with other partnerships, of course, with clean hydrogen, because hydrogen is also an important future fuel for this sector, the batteries partnership. So we are really looking into that now very, very closely, especially for the work program 2023-2024, which we are developing right now, and where we also have, for instance, coordination and support action for better coordination with member states. So because we know member states also have programs, and the goal is not to duplicate, is to know what they are doing, that they know what we are doing, and that we work together and in a complementary manner. Another important instrument, and I don't know if it was mentioned because I could not follow the whole session this morning, is the alliances. Because as I mentioned, we want also to build up the Green Deal at industrial and market-oriented, at industrial level, but also in a market-oriented manner. And now DG Move just launched, it was Friday last week, these alliances, and if I have to, for renewable and low-carbon sustainable alternative fuels. I think something like that. It's quite a long name, but okay, you understand what I mean. And where they really try to gather all the industry, and from the production to the distribution, and of course to the end use. And I think it's also very important for us to be in contact with them, because I mean, this alliance was developed or created mainly for the shipping, Waterborne, and or Maritime even more, and aviation sector, because you know they have new legislation coming up, Refuel EU Aviation and Fuel EU Maritime. So I think it's very important. Your sector is one of the main sectors why this alliance was created, and I think we should also interact with them. I think. And as Rosalind mentioned in the morning, I mean, the Waterborne sector is a very dynamic sector where you have, I think a lot of things happening, and I see also that the industry and all the associations are very active. So I think it's very good and very, I think for us, very rewarding to work with such a sector. So we really try to make the best of it and try to turn the challenges in opportunities, as I was mentioning, also looking at markets, at business opportunities. And the zero emission Waterborne Transport Partnership is, of course, our main instrument. But as I said, we also look at to coordinate with other instruments. So I think it's very important for us to keep in touch with you, and also to be very close to the project, to the results, to use it in our future policy and future project. Voilà. And now I will give the floor to Marcel from CINEA, and I guess he's on the screen now because I don't see him here in the room. So Marcel, Marcel is here. Yeah, good. I will just submit.
absolutely marvellous. Thank you. Thanks,
I'm
Jane.
there on the stream. Good afternoon, everybody. Ladies and gentlemen, and thank you very much for inviting also me to share some words with you. I mean, first, I would like to highlight that transport research and innovation in the field of waterborne transport is very important for us, for the program, for the agency, and also for the project portfolio in my unit in CINEA. And I think you have done an excellent work during the past years of Horizon 2020, but I also want to highlight that my colleagues have done a fantastic job in helping you to move forward with all these very interesting and good projects. I've attended part of the event, and I think it has been a very interesting and especially also a very rich event. And I want to highlight rich because it's clear that there has been a lot of work ongoing in a variety of areas. As a main message, perhaps, when I look at this richness of projects and richness of results and activities, I think it's important that we stress the importance of communication and dissemination of the results. Future work has to build upon what has already been done, and future work should also push further forward towards deployment of the successes that we have seen today. We are there also to help you with this further pushing forward to deployment. First, we are waiting for your success stories. We can help you spread these results through our social media. It was already mentioned that we have produced a Water-Borne brochure. This is another way of how we can help you. But of course, we have a lot of additional tools in place, especially when we talk about scaling up. There are, of course, the opportunities of the new Horizon Europe program, but there are also what I could call internal tools. There is the Horizon Results platform that is available. And when I talk about funding opportunities and future funding opportunities, I mentioned Horizon Europe, but there are other programs such as the Innovation Fund that can also help. I don't have a lot to add to what already has been said, and also what Jane already has mentioned on the importance of the new partnership that will further strengthen the activities of the waterborne sector in the program, in line with our political priorities. But perhaps a short final message from our what I would call internal kitchen. I mean, please help us also to disseminate our Waterborne brochure. It gives a very good and very interesting overview, I think, of the projects that we have financed in Horizon 2020. And then looking a little bit in the short-term future, but I'm sure you're all very busy already with working on proposals. We have a call deadline, an important call deadline on the 26th of April, where 12 waterborne topics are open for proposals, and we are looking forward to looking at these proposals and working with the expert evaluators and selecting the most promising proposals for extending our project portfolio in the future. Perhaps as a last comment, I want to thank all for organizing this excellent event. I think it really has achieved its objectives. It really has highlighted the fantastic work that has been done over the past years. And we in CINEA and my colleagues are available and in case you have any also follow-up questions beyond this workshop. And thank you very much for your attention. Good afternoon.
Thank you. I just want to say, on behalf of myself, thank you all very much for being so tolerant of my woeful pronunciation of everybody's names. And thank you all to the online audience that have stuck with us and learned, I hope, a lot. It's the power of technology that enables us to do this. So thanks, everybody. I'm going to hand you over now for the closing session to Jaap Gebra, who has organised all of this for us. So thanks, Jaap.
I first of all want to thank you, and I know you have to catch a train back to the UK shortly after 4:15, so I will not continue until 4:15. But there are a number of things following up on what Jane already said and what Marcel said, which might need to be good to conclude also for us internally in the Waterborne TP to see, okay, which next steps will we take. But maybe first a number of practical issues. We had about 540 registrations today, so I would like to thank everybody in the room, but also online, for joining, because I think that shows that we as a sector are able to cooperate. Not only the participants, but also the speakers today for dedicating their time and their efforts to make this event a success. The moderator, it was not an easy task, it was already not easy to come here yesterday. The audiovisual company for ensuring that everybody was able to participate online without actually any interference, and the colleagues in the context of the Flair Project for organizing this event, and the colleagues from the European Commission Services, RTD and CINEA for co-organizing this event, because I think we were already busy from October with organizing what we had today. Today, for me, highlighted again the power of cooperation and the ability of our sector to cooperate, and the sector in the broader sense of the word. So not only, and only is maybe the wrong word, the traditional players in the sector, but the broader sector in terms of zero emissions, but also in terms of connected and automated, whatever that definition is. I will come back to that a bit later. As already said this morning, we have a quite diversified, I would not say fragmented, but diversified, because diversified sounds a bit more positive, sector, which is in the end unified towards reaching the same objective, but with various needs. And for us, certainly in the Waterborne technology platform, it's always seeing how can we fulfill all these needs without and still do it jointly. And besides this, I think we are well aware of a turning point for our sector, a turning point in terms of policies, the European Green Deal, the IMO, which is stepping up in terms of the environmental outlook, but also the turning point, and specifically in some segments caused by the COVID-19 pandemic. We cannot overlook that in some segments of the waterborne transport sector, we are at this moment in time in a heavy crisis with a number of insolvencies or bankruptcies already last week and the week before because of the effects of the COVID pandemic. So the sector will have to reinvent till a certain extent itself. But once again, we are working together regarding the issues with a common interest: research, development, innovation, and certainly also the deployment, which has been highlighted a couple of times in other interventions as well today. For us, the message received today, both from the public side but also from the private side, stimulate us to continue these efforts. Efforts regarding zero emission, zero emission, safe and secure, and also competitiveness. But certainly what I take away today is the increased attention for digitalization. The exercise we started internally is, first of all, do we understand the same with digitalization? I heard in one of the panel debates, autonomous versus unmanned. Is that the definitions we are working on, or is it broader? Is it the integration into the entire logistics chain? Definitions we are currently working on to see, do we speak the same language, and then what do we need? What do we need to achieve a number of objectives? And most important, when you want to work on an R&D roadmap, where do we stand at this moment in time? For us today, and also for a number of colleagues here, is not the last event of this year. From tomorrow onwards, we will start prepare the participation to the SMM in Hamburg, which is scheduled for September this year, and I hope it will be an in-person event. And as well, increase our preparations of the TRA 2022, scheduled for the 14th to the 17th of November in Lisbon, which I think will be another key event for R&D regarding the transport sector, the broader transport sector, but also Waterborne in general. Now, a number of practicalities, all the meeting materials of today, the presentations, the booklet, which has been launched this morning, and other materials will be distributed. I cannot promise it will be today, but then it will be tomorrow morning. And the materials will all be uploaded on the websites of the Flair Project, which organized this event, as well as on the Waterborne Technology Platform website. A press release will be launched, but I think not more important, but also important, at this moment in time, we are updating our strategic research and innovation agenda regarding zero-emission waterborne transport. It has been adopted by the Partnership Board only in September, I think, last year. But we have a strategic research and innovation agenda on a rolling basis. And we are currently looking at what is the state of play and what will be the next steps. And why is this important? Since we will, in that process, launch an open consultation. So everybody who want to provide contributions, input to the state of play is more than welcome. And any follow-up questions after today can still be answered by contacting one of us by email. And then I think we can call it a day. I was not allowed to say that we close the curtain, so we simply close the event. And I wish you all a pleasant day and a safe trip back home.